Welcome. Today we're going to talk about modeling with exponential functions. And exponential growth, exponential decay, those are the two types that we're working with. Y equals A times 1 plus r to the t is an exponential growth. Y equals A times 1 minus r to the t is exponential decay. A is the initial or starting amount. R is the percent increase or decrease. And the quantity 1 plus r is the growth factor. The quantity 1 minus r is the decay factor. So if you add a percent, like 45% is 0.45, and that would fill in for r, and then you'd add or subtract depending upon the problem. Now, when you add that, that makes this value greater than 1, and that we know is a growth. Remember, B, growth, had to be greater than 1, and this is between 0 and 1 if the percent is like 45%. So that would be the decay factor. All right. 1 year, a clothing company has 1.5 million in sales. In later years, sales in millions of dollars increase by about 25% each year. So Y equals the initial amount, 1.5, and that's in millions. 1 plus, because this is a growth, 0.25 to the t. Now, we can also write that as 1.5 times 1.25, add the 1 and the 0.25 to the t. 8 years later, what would their sales be 8 years later? Well, Y equals 1.5 times 1.25 to the 8th power. Now, if I actually use my calculator, I'm going to get some very long decimal, and I'm going to use the whole decimal, 5.9604, let's see, 64478. That times 1.5. Now I'm going to round the final answer, but truly, the full answer is more accurate. 8.94, and the decimals keep going in millions of dollars. So the sales after 8 years would be $8.94 million if this holds true. A lot of businesses will use a growth factor or a exponential growth type of model to do their business model to show how much their sales will grow over time when they're trying to get a loan. All right, let's take a look at a computer. You buy a new computer for $1,500, maybe it's a gaming computer. The value in dollars of the computer decreases by 40% each year, and what would that be? So Y equals 1,500, the initial amount that it was worth, times 1 minus 0.4 or 0.40 to the t. 40%, 0.40 or 0.4. Now, when I write this out, .6. 1 minus 0.4 is 0.6. So, after 3 years, what's it going to be worth? 0.6 to the third, that's going to be 15, that's better, times, let's see, what's that come out to, 0.216. And now the final answer, after 3 years, it's worth a whole $324. Not a lot compared to 1,500. But you know how fast technology changes, and the faster it changes, the more quickly an item becomes obsolete. Let's take a look at our next example. All right, for problems 26 to 28 in the book, you deposit $900 in an account that pays simple interest. So I equals PRT. Each year, the amount in the account increases by 2.5%. Write an exponential growth model that represents the balance after t years. So y equals 900 times 1 plus 0.025 to the t. There is your model, or you could finish it off and say 900 equals 1.025 to the t. The next thing it asks is for you to graph this. So I need to have some points to graph. Remember, t is like the x value, and y is the outcome. Now I'll need to get my calculator to do this, because this is going to get a little bit difficult to type in if we don't. We know that the starting value is 0, and that's going to be 900, because anything to the 0 power is 1 times 900 is 900. When we put in 1, 900, 900 times 1.025, that's $922.50. If I put 2 in, I get $945.56. 3, $969.20. 4, $993.43. And let's just do a couple more. 5 and 6. 5 gives you 1,018.27, and 6 gives you 1,043.72. Now, what does it ask after that? After 5 years is 1,018.27. Now let's plot these points. Now, we're starting at 900 for the y value. Would it make sense for the graph to go from here up to 900 by hundreds, for example? Well, it'll be okay, but sometimes, have you ever seen this little symbol? And that means there's a break in the graph. And sometimes they'll label this 1, 2, 3, and they'll label this 0, but then they'll jump to 900. And maybe, let's see, how much is this going up by? Maybe we could go by 20s. 920, 940. 980. 1,000, 1,020. Now our last value was 1,040 something. So that would be 1,040. So sometimes you do have to approximate like this. Now I just shifted the XY to the far corner. You could do that on your own graph. Let's see, 0, 900 was the first point. The next point was just over 920. So that's about here. That's just a tad over. The 945, 940, 945 would be about a quarter of the way to the next one. The next value would be 969, then 930, 93. 969, almost halfway. 993, was it? 4, 993. 1, 2, 3, 4. 9, 9, 20, 40, 60, 80, 93. And then 1,018 for 5, 1,000 almost to there, and then 1,043, almost 44, 1,043 for about there. It's not quite a straight line. It is a bit of a curve here. And I probably should have put dots over these. It is a bit of a curve. If we looked at it on Desmos, I think you'd see the curve eventually show up there. But I would do the table out at least to the number that you're asked for, or at least the first few, and then use the value here, type in 5, so 1.025 to the 5 equals, that's 1.1314 times 900, and that gives you 1,018.27 when you round it. So do your best with the graph. Let's take a look at another example. All right, this is different. Write a function of the form y equals a times b to the x whose graph passes through these 2 points. All right, let's see what we can do here. First, this is the x, this is the y. We need to know what a and b are. So I'm going to fill in x and y in 2 different equations. So y is 6 equals a times b to the x, which is 1. Y equals 18 equals a times b to the 2. All right. So the thing I want to get by itself is the a, because I have the same a in both of them. So I'm going to divide by b to the first, or just b. So a equals 6 over b. I'm going to substitute that in for a here. 18 equals 6 over b times b to the second. Now I want to reduce. I can reduce these b's. That's a b and that's a b. B to the first. So 18 equals 6b. Now I'm going to divide by 18. B, not 18. So used to the value being on the other side. I'm not dividing by 18, I'm going to divide by 6, because 6 is what's multiplying times b. You don't divide by 18, so b is 3. Now if I bring that back over here, a is 6 over 3, or 2. Now I have 2 answers, a and b, and I'm going to take those and write the equation. Y equals a, 2, times b, 3 to the x. There is your equation. Y equals a times b to the x, y equals 2 times 3 to the x. If it helps, put that in parentheses so that it makes it obvious what the b is. All right. Give this a try. This one's a little more difficult. Give it a try. I'm going to do it out as soon as you finish doing your best and unpausing it. Here we go. All right. 3 equals a times b to the second. 12 equals a times b to the fourth. Divide by b squared. A equals 3 over b squared. Not b, b squared. All right, when I substitute over here, I'm going to put 3 over b squared. times, not equals. That last part should be purple. There we go. Over 1, these reduce. I get 12 equals 3b to the second, fourth, and second. Now, I'm going to divide by 3. That's 4 equals b squared. And then I'm going to square root both sides to get b equals 2. Now, I'm not going to use the negative of that. I know I could use plus or minus 2, but I'm not going to use the negative because I'm not going to be having a negative value that is being raised to a power in terms of this function. Otherwise, it fluctuates back and forth and it causes problems. So let's use 2 squared, not just 2. Frequently people want to just stop there with 2, but it's 2 squared. 3 over 4. There's my a. So y equals 3/4 times 2 to the x. There's my equation. Y equals 3/4 times 2 to the x. That's my final equation. That's what I was looking for. Compound interest. The formula is down in the right corner. A equals P times 1 plus R over N to the N times T power. Complicated, but not difficult when you take your time and simplify it. P is the principal, or the amount you borrow or invest. R is the annual interest rate. N is the number of times per year it is compounded. T is the number of years. A is the amount in the account at the end of the time frame. All right, let's use it. Find the balance after 4 years if you deposit $1,400 in an account in Bank Y. Now, Bank Y in the table says it has an interest rate of 3% and it's compounded quarterly. Now, if something said monthly, I would say 12 times in a year because there are 12 months in a year. If it says weekly, there are 52 weeks in a year. Quarterly, every quarter, or quarter of a dollar, 1/4, so 4 times a year. So A equals the initial amount or principal, $1,400, times 1 plus R 0.03 over, what was that, 4 quarter time N, right? To the N, oops, not 3, 4. N is 4. And number of years is 4. There's your starting point. Now I'm going to do this calculation here first. 0.03 divided by 4 is 0.0075. And 4 times 4 is 16, obviously. $1.0075 to the 16. And when I raise 1.0075 to the 16th power, I get 1.12699 2114. I believe those are 2114. All right, so when I do this all out and multiply, it comes out rounded to the nearest penny, $1,577, oops, not decimal, decimal, 79 cents. And that's in dollars, of course. And that's how much is in the account when it's compounded quarterly. Now, if that's an interest, and that is something that you want, that you're earning, that's great. But when the interest is on a credit card and you're having to pay that interest, that's not so great. All right. There is your homework, and that is it for today. Have a great day.